This section examines the battery. The wet cell lead-acid battery is the main storage device in automotive use. An automotive battery can supply very high discharge currents while maintaining a high voltage, useful for cold starting. It gives a high power output for its compact size, and it is rechargeable. The battery provides a source of energy to supply current to the ignition primary circuit for initial starting purposes. It forms part of the ignition primary circuit and acts in conjunction with the alternator to supply current to the ignition system throughout engine operation. It is also used as a conductor in the secondary circuit, providing a path for the high-intensity current generated across the ends of the secondary winding when the primary circuit is interrupted. This section examines batteries and cells. Electrochemical cells transform chemical energy into electrical energy. There are two types, primary and secondary. In a primary cell, this transformation is not reversible, and the cell is discarded at the end of its life. In the secondary cell, the transformation is reversible, and it can be recharged. There are two types of secondary cell, wet and dry. In automotive use, the usual main storage device is the wet cell of a lead-acid battery. It has two plates of dissimilar materials immersed in an electrolyte, a solution that conducts electricity by using ions. The accepted or nominal voltage of a cell does not depend on the size of the cell. However, current capacity does. The surface area of the plates in a cell determines its current capacity. In a lead-acid battery, the plates are assembled so there is always one extra negative plate. The plates are close to each other but do not touch, which would cause a short circuit. The nominal voltage of a cell is 2 volts. Cells connected in series make a battery, and the number of cells determines its nominal voltage. The cells are sealed from each other and filled with dilute sulfuric acid. The battery case is usually plastic or hard rubber. One set of plates is connected to the negative side of a DC source, and the other to the positive side. Direct current is applied to the plates, changing them chemically until the battery is ready for service.
Switch on the ignition. The charge light on the dash should light up and go out when you start the engine. This indicates that the alternator is charging the battery. Turn the engine off. Switch on the headlights of the vehicle, then start the engine and see if the lights brighten significantly. If they do, then this indicates that the alternator is charging the battery more than it is being drained by the lights. If you do not have someone else to start the engine for you, judge the brightness by shining the lights onto a reflective surface such as a wall. Check that the battery casing and the terminals are in good condition. This can generally be achieved just with a visual inspection. However, since the battery may be located in a position where you cannot see all of it, you may have to remove it to complete the inspection, after performing any other on-car tests. A sealed or low-maintenance battery has no removable cell covers, so you cannot adjust or test the fluid levels inside. However, some of these do have visual indicators that provide information on the status of the charge and condition of the battery cells. Each manufacturer provides details of these visual indicators, so refer to these when undertaking an inspection. If the battery is not a sealed unit, it will have removable caps or bars on top. Remove them and look inside to check the level of the battery fluid, which is called the electrolyte. If the level is below the tops of the plates and their separators inside, add distilled water or water with a low mineral content until it just covers them. Be careful not to overfill the cells, as they could boil over when charging. Test the specific gravity of each of the cells by using a hydrometer designed for battery testing. Draw some of the electrolyte into the tester and look at the float inside it. A scale indicates the relative charge state of the battery by measuring how high the float sits in relation to the fluid level. A very low overall reading of 1150 or below indicates a low state of charge. A high overall reading of about 1300 indicates a high state of charge. The reading from each cell should be the same. If one or two cells are very different from the rest, that indicates there is something wrong with the battery. Select the volts DC position on your DVOM and attach the probes to the battery terminals, red to positive and black to negative. With all vehicle accessories switched off and the battery at 70 degrees Fahrenheit or 21 degrees Celsius, the voltage reading should be 12.6 volts if the battery is fully charged. This will be slightly lower at cooler temperatures. Measure the continuous load capability of the battery with a load tester. Refer to the manual of the particular tester for its operating instructions. A load tester induces a high rate of discharge in the battery, like the load created by a cranking starter motor. A battery is rated in ampere hours, which means that it can supply a certain number of amperes for a specified length of time under continuous load. Another measurement used is International Standard Cold Cranking Amps. Check the specifications for the battery you are testing. If it can meet these specifications under a load test, then it is in good condition. There are different makes and types of load testers. Always use the equipment manufacturer's recommended testing procedure.